Hello, Tom from Every Step Physics, EveryStepCalculus.com. Physics problem about finding amplitude and phase of a problem. You can see it on the screen here. And how my programs answer that one. You can go to my site, buy my programs for $30. www.everystepphysics.com. You get over 350 programs that you load into your TI-89 titanium calculator, and it solves your physics problem step by step. And of course you'll have them for the rest of your life. You can throw your physics book out, worthless when it tries to answer the actual questions that we have for tests and homework. The theory is there, and professors and authors try to show everybody how smart they are, and they answer questions in that way, and they forget the simple stuff that we need to actually answer the question. So anyways, physics, to get to my menu, it all comes with instructions. I'm going to go up because S is closer to the bottom of the alphabet than the top, so I'm going to go scroll up and go to the bottom of the alphabet of my menu, and I'm going to scroll up to the S section and look for springs. You have to get used to my programs. You have to look through them and study them a little bit. You look at the menus, find out what's offered there. Generally, I have a system of doing this stuff for physics. Certain things like bullets and bow and arrows and springs have their own menu item, but other things that you might be asked in physics problems, such as collisions or acceleration or tension or velocity, those have their special menu items that you can go in, and then the next menu gives you the variables that are given. So anyways, we're at spring calculations, and we want to do a horizontal spring. Number 2. You can press the numbers or scroll to it with your cursor here, or press the number 2, and then we're going to find the variables, and we have mass here. I always write them on the side of my paper so it doesn't confuse me. Write 210 grams for mass, 280 hertz for frequency, and X is the stretch of initial stretch of a spring, and then it has velocity, and it's supposed to go into simple harmonic motion if you try this stuff in the space shuttle or without in a vacuum. So here's mass, velocity. We don't want that. We want to scroll down here to, that gives you the angle. Here's mass, velocity, stretch, and frequency. Okay, so we're going to choose that, and we're going to add our variables. We have to press alpha before you enter any variables into these entry lines here in my program. So we're going to press alpha 210, and it's grams. I do the conversions and show you how to do that, so you can write that on your paper, look like a genius. We're going to enter the initial velocity, which is 27 centimeters per second. Alpha 27, number 3 centimeters per second. I'm going to press number 3 here on the calculator, and that gives you, if it's given, you'd put that in there. But for instance, whether you're going to the right of the x-axis or the left of it, east or west of it. But if it's not given, you just press enter and it goes to the next variable asked or given. So we're at the stretch. X equals 5.8, alpha 5.8 centimeters, number 2, and we're going to enter the frequency, which is 2.8 cycles, alpha 2.8. I always show you what you've entered. You can check it if you want. Here we have mass 0.21 kilograms, velocity 0.27 meters per second, the stretch is 0.058 meters, and the frequency is 2.8 cycles. I say it's okay, and we do our calculations. Now I'm giving you much more than the amplitude of the phase, but you never know what they might be asking on these things. So, angular frequency, and then we find the spring constant. All these you write on your paper, whatever you're interested in, because it shows you how you're working the problem. You show your work, which is important in calculus and physics. Potential energy and kinetic energy, and in this case we're going to add them together. Total energy, and then we can find the amplitude by using these formulas. Now physics, you have to memorize about 300 formulas and supposedly recall them in 2 seconds in a test, and to me it was extremely difficult, so I needed the calculator and programming to do it, and plus you have it for the rest of your life too. Now there's two different. This is simple harmonic motion, SHM. In other words, the spring is going back and forth when you set it into motion. Vertically, notice we're in the y-axis, so you're using y for that. X-axis, in a horizontal spring, you're going right and left. But both of them can be set into motion and will bounce up and down, okay? So the calculation for phase and amplitude is, sometimes professors use the sine and other ones use the cosine. Mostly time, well, both my physics books, one uses one of each. And so it depends on what your class instructs you to do. So I give you that choice. Right now I'm going to use the number 2 cosine system. And so x is equal to the amplitude times the cosine of the angular frequency times the time, and plus phi. Phi is this indicator here. And so we know the stretch, which is 0.058, which is over here on the converted, of course, to meters. And then we do the calculation, then we do algebra and switch the things around. We're trying to find the cosine of, we find the cosine of phi is 0.967, and the next screen does the calculations just like this, as you would on your calculator, and it comes up with 14.821 degrees. And if we multiply that times 0.017453, we get the rads, which they ask for in the, your professor may ask for one or the other, or both. And then we can find the, because we've got the amplitude, we can find the maximum velocity, and we can find the acceleration, okay? Amplitude times the angular frequency squared. Now we can go back and we can look through the answers again if we want. Sometimes it's helpful to do that. I'm going to do it quickly here. and then we can press number 2 and go back and do a new problem or whatever for your test or homework. Hey, go to my site, buy my programs, and enjoy passing physics, okay? Have a good one.